Welcome to Chicory's maintenance series. I'm going to wrap up a couple projects that were in previous videos and give you some additional information. I'm going to include the Maretron DC monitoring system in this video and the pump, low pressure pump for the water maker and the saltwater washdown, the rebuilding process of that. So let's start with the Maretron. In the last video, you saw me send this unit back to Maretron because they had determined it was defective. They put this on a bench and tested it. But I had sent them this unit along with the Hall effect sensor that tells it how much amperage is flowing through this sensor. I contacted them recently because I had readings that were way off. If you remember when I originally tested it, it seemed pretty close, but I wanted to make sure that everything was right. But once I was out at anchor and putting some serious amperage into the battery bank, I saw that it was measuring half, basically, of what actually was being put in. And so obviously that's a serious issue. So I sent an email to Maretron and say, hey, when you tested this unit, did you also test the Hall effect sensor? And I think what happened, they never gave me an answer, but they did say that, you know, they tested this, they found it was wrong, and they just sent me this back. Well, they concluded that yes, there's a chance that both of these were wrong, and they sent me a new Hall effect sensor. I'm pretty hopeful about this because I'm noticing that there's a different part number on this one. Even though they look almost exactly the same, there's a different part number. So I'm hoping that there's been some improvement made to this or something. So I'm going to replace this right now, put this in place. But one of the things I need to do, just to make sure everything's good, is I'm going to disconnect the lead wires from this Hall effect sensor, hook it to this, and zero this out with the Maretron system. So it knows that there's no amperage flowing through. It's just basically a calibration. And then I'll put it in, and then I'll end up testing it over the next couple weeks. So I'm going to do that now. But the first thing I need to do is I'm going to shut off the N2K network because I don't want to be unplugging and plugging things when they're live. I'll be back in a second. Okay, so I shut down the N2K network. I have this Maretron cable hooked up to this Hall effect sensor. I have it sitting here because I want current flowing around it so that it doesn't get distracted. It should only be measuring what's inside. I don't want to be having it set out here where there is no magnetic fields around it. So I want to make sure that only electricity that flows through the Hall effect sensor is sensed. So I'm just going to set it here just so I've done everything I need to do with the calibration. Then after I turn the N2K network off and zero it, I'm going to move it away from a magnetic source and make sure that no voltage is different. It should not affect it at all, but it's just before I go through the process of including everything, I want to test this. So we're going to go up now to the pilot house and look at the Maretron N2K analyzer, and I'll show you how all of this works. So this is the Maretron N2K analyzer, and I've got highlighted the DCM100, which is the DC monitoring system. So I'm going to, once it's highlighted, right click on it and say configure device. And then it comes up with all the configuration that you can do. So one of the things that you'll notice here is it's measuring a battery current of negative 0.04 amps. The reason that's important is you just saw downstairs that there is no actual current going through this. So I'm going to current sensor zero offset calibration. I'm going to click this, and then I'm going to say OK. Now it's back to zero. Now I'm going to save configuration to the device. So what this does is that black box that's downstairs will save this memory that it's zero. So Tracy is actually holding the camera now. I'm going to go downstairs and move the Hall effect sensor away from the magnetic field that is around it right now. It should stay at zero. She'll call out to me if this changes anything from zero. So I'll be back in 1 second.
No. No. No.
So now that it's zero calibrated, I'm going to shut down the N2K system. I'm going to install it, and then we'll come back here again and look and make sure that it matches what my shunt reads. So I'll be back in a minute. Okay, so I'm back. The Maretron N2K system is shut down right now, and I have to remove this battery cable so that I can get this Hall effect sensor out. And if I do that, my entire lithium iron phosphate battery bank cannot feed my two 100 amp breaker panels that are upstairs, which go through this. So what I'm going to do is I have a system set up here where my main engine and my alternator battery switches are within here, and I have this cable that runs down to this bus bar. And what that means, if I switch this to 1+2 and 1+2, that means that I'm combining this wire with the batteries that start my engine and start my generator. They're going to be my temporary batteries when I disconnect this wire. So the chargers will come up in here. This bus will be isolated. It'll have two chargers, it'll have 3 batteries, and it'll be able to feed my DC loads right now while I disconnect this. So that's the plan. So I'm going to take care of this right now. The first thing I'm going to do is take off this protective shield. This isn't ideal because I have this wire connected to this lug. So instead what I'm going to do is I'm going to take off this bottom one and pull the Hall effect sensor off the bottom so that I don't disrupt that other battery. And the fact that I'm going to disconnect just this one bank of batteries is no big deal. So I'm just going to grab my wrench. So I've talked about this in the past, but I'm very careful about keeping my hand on the wrench because I don't want this to touch anything that could ground, because that would be bad, because there's a whole lot of amperage right there. So I'm going to come in here and very carefully just break that loose and then get the wrench out of the way. I'm going to pull this nut off, and then I'm going to take a screwdriver and unscrew the Hall effect sensor. So now that I have this loose, I have this battery cable on the outside, so I'm going to pull that off first. They both kind of have to come off at once. I'm going to pull the Hall effect sensor off. I'm going to grab the new Hall effect sensor, and I don't know if you can see that, but there's an arrow, and the arrow is supposed to point towards the batteries. So I'm going to slide this back on that major cable, slide it up in its position, and then I'm going to put battery cables back on. Looking for the nut. I'm going to put the nut on. While that's there, I'm going to switch the ratchet to tighten. Come in here, making sure my hands are holding everything the way they should. Not going to hit any grounds. That's super tight. Next thing I'm going to do is take the screws that hold. Well, actually, you know what? I'm going to do one thing first. I'm going to take the wire and I'm going to hook up the lead wires to the Hall effect sensor. Okay, they're on now. I heard it click in. So now I'm going to take the screws that hold the Hall effect sensor. I'm going to put it back in the position that it was. And one of the things that I'm doing to make sure that this has the best chance of working is I'm making sure that the 4/0 cable that has all the current going through it is centered in the Hall effect sensor. You shouldn't have to do that, but I want to make sure that I'm giving this all of the chance it can have to make sure that there's no anomalies. I'm very happy the way that is. Cable's there. Now, I'm not going to put the protective guards on here until I go back up and compare the Hall effect sensor to my shunt and see how close they are. And that'll necessitate putting the N2K network on and getting everything up and running. So it'll be a second, but next time you see me, I'll be up at the Maretron computer. So we're back at the Maretron system. Once again, the DMC100 is selected. I obviously flipped the breaker back on so it's activated. Once again, I'm going to right click and say configure device. And so right now you can see the battery current jumping around. Right now the charger's on and it's at float, so that's why we have such small voltage and it's jumping around. But what I'm going to do now is I'm going to go down to the Xantrex control panel. I'm going to turn off the charger and put some DC load on here, and I'm going to speak out what I see on the shunt, and Tracy's going to tell me how close I am to the battery current that the Hall effect sensor is reading on the Maretron system. So I'm going to do that right now. As you know, the panel is right here, close by. So I'm disengaging the charger right now. And with no load, just the kind of house load right now, I see 8.7 amps. What do you see, Trace?
Negative 8.6.
All right, so I'm going to put a load on just to see if we load it up just a little bit more. I just turned a fan on. I'm at 16.4, 16.5.
16.5. Though it fluctuates a tiny bit. Now it's 16.4.
Okay,
It's
mine's
fluctuating
fluctuating between the two as well.
Okay.
I'm going to turn on engine room lights. I see 23.1.
I see 23.2.
Okay.
Nope, now I'm up to, yep, that's correct.
I'm going to put floodlights on and another blower. I'm at 28.2 right now.
Correct. 28.4, 28.3, and 2 again. It's fluctuating between them.
Okay.
Now we're at 28.3. That seems somewhat stable. Nope, it did change again.
Mine's blinking between 28.0 and 28.1.
Now I'm at 28.0, 28.2, 28.1.
Okay. This is about as high of a load that I can put on reasonably at this point in time. So I'm going to do what I said last time when I did the first video on this, is we're going to live at this at anchor, and when I put 300 and some amps into it, I will look at what Maretron is saying I'm doing, and we'll see how close they are. So I'm back down below. I'm going to put these guards back on and put everything together here, but I don't think you need to see that. So I'm going to move on to the section of this video that is the pump. So look for that right now. So this is an update on the water maker and saltwater washdown on the bow low pressure pump rebuild process. In the last video I showed that I redid the seals on this pump, but the shaft was completely destroyed, so I bought a new motor. Got it from Motor Warehouse. It was $388 and then $415 with shipping, so a relatively okay price. So I'm just going to reverse what I had done before and just unscrew the volute with all of the plumbing in place. And then gently pop this off, trying to make sure that the O-ring is still in good condition. I'm going to set this aside. I'm going to pull off the O-ring right away. Still looks like it's in good condition. I'm going to put this inside just for 1 second to make sure that it doesn't get damaged. And You've seen this drill before. I'm just going to lay out a towel here because there's a little bit of moisture from inside the pump. But I need to take this plug off the back side. Need to take a standard screwdriver, fit it in the back to hold the shaft, turn the impeller counterclockwise, comes right off. Slide that off. I'm going to set that aside. I'm going to flip the motor up. And last time I tried to grip this and pull this off, and I did a little damage. I'm going to actually just unbolt this time and pull the back part of the pump off and hope all of this comes with. This seems to be working very well. The seal is coming off. I'm just putting my hand over it because, as you know, it's spring loaded and I don't want, there it goes, it pops off. Looks like the seal is still in good condition. Then I'm going to pull this part off. So this has been about a week. I don't know if you can see this, but there's some rust already on that ceramic. This shaft is rusting so quickly. So I'm going to put this pump down, and I'm going to move this pump over here, and I'm going to bring the camera down and show you a comparison close up. So I just want to show you the new shaft and the old shaft. You can see how dramatically different they are and how really bad this shaft is. I guess hindsight, looking at it, there's no doubt it was going to leak, but I had hoped that there was a chance that it would stick. I'm going to try and repair this shaft, as I said in the last video, but I'm going to start reassemble this, but I want to show you one thing that I'm considering first. So I want to show you one of the things I was thinking about. I wish this would be designed this way. So the impeller, when it screws into the shaft, actually pushes on this seal and compresses it a little bit. I think you can probably see the spring moving a little bit. The thing that frustrates me about this is, had they made this surface a little bit larger diameter so that it was equal to the size of the seal, they could have put an O-ring in the back of this impeller that would have sealed up against this metal surface, and not only would water not get down the shaft because it has this double rubber seal, but that O-ring would help seal so no water got to the shaft at all. That would be such a better design, and I don't understand why, when engineers are designing this kind of stuff, that they don't do these simple little steps to just make the molding a little larger, put an O-ring in there, and you'd never have this problem. Frustrating. Anyway, I'm going to put this stuff back together, and I'm going to start that right now. So I'm ready to assemble. I've got a little bit of rust on this ceramic, so I'm just going to take my towel that I have here, clean this up just a little bit. This is strictly cosmetic, but I want to make sure that when I put this back in, there isn't anything that can wear this ceramic more quickly than necessary. I can actually see the gray line where the graphite ring is riding against it, and all the rust is inside that ring, so I think everything's good here. And then I'm going to just line this up. So this is the top of the motor, and this goes on like this. Put the 4 bolts in. Now I'm going to take the seal, make sure the shaft is clean of debris, and I'm going to press this on, And it slides on much easier than the last time, because the last time, of course, there was all those issues with the scoring of the shaft. So I've got that on. I'm ready to put on the impeller. I'm going to flip this around, put my screwdriver in the back. Oh, gotta pull the plug out one more time. Put that in there. Tighten this down. That sounds good. I'll put the plug back in. Rotate this back up. Now I'm going to get the silicone waterproof lubricant and the O-ring before I reassemble. I'll be back in 1 second. Okay, I'm back with the O-ring. I have the waterproof silicone lubricant on my fingers. Just like last time, there's a little flaw in the O-ring, and I'm going to put that towards the top. Under pressure, it doesn't really matter, but it's just something I want to do to make sure that everything's the way it should be. Just going to finish the lubrication there, and a little bit that left on my hand, I'm going to just put in the inside of this groove. Wipe my fingers off a little bit, and then lay this back on. I'm going to lay it down one more time. Do one last tighten just to make sure everything's the way it should be. Okay, everything's done. The old motor is off, the new motor's on, and now we're going to install it and make sure everything works. Okay, so I'm ready to test the pump. I have to prime it again first, so I have the freshwater washdown, but I do have, I'm actually going to send this to the foredeck so that I don't run this marina water through my membranes. So I'm going to turn this on. The water pump is pumping now, domestic water. I don't see any leaking. Okay, I'm running the pump and I don't see any water coming out. Everything looks fine. I'm going to go up on the deck right now. So I've told you before that I have a salt water washdown for that pump. So I'm going to go behind Tracy here and show you. So we have a deck fitting. We've got 15 feet of red hose, and then we've got a little wand that we use so Tracy can reach down and clean the chain. And that has so much force that it actually is hard to hold down. So it's pretty amazing. So normally I never do a freshwater flush when we do the salt water wash down at the front because I haven't thought it was necessary. I do that, of course, when I'm doing the water maker flush. But so I think what we're going to do from now on is do a freshwater flush of the pump when we do saltwater wash down in the front, and that way at least there's not salt water sitting on that shaft. So I'm just going to do this a little bit longer. Looks like it's even sealed with the pressure from the pump, which is good, impressive. So I'm going to say that this is a success. I'm going to shut the fresh water off and say it's good. At this point, I'm going to close out the video and say thank you for viewing, commenting, liking, and subscribing. Until next week, thanks.